In these next examples, we're going to convert each term with rational exponents into radical notation form. In order to help us with that, remember that each base is raised to a power over root. So if we look at example 13, x to the 5/3, 5 is the power, while 3 is the root. So that means cube root of our base of x raised to the power of 5. Now we're not intending to simplify anything here. We're simply converting from one form to another. So we started with rational exponent. Rational means a fraction, so the exponent is the fraction 5/3. So we converted this base raised to a rational exponent into its radical notation format. In example 14, we have 2x to the half. Now what's important here is knowing which base is raised to the power. Only the base of x is raised to the power of 1/2. 2 is not included because there is no parenthesis saying to include it. So this breaks down as 2 being multiplied by x to the half. Remember, the top number in that rational expression is the power. The bottom number is the root. Root of 2 is square root. Our base is x raised to power of 1. So we don't need to write a 1. So we're done. 2 times the square root of x. In example 15, I have a to the negative 2/3. Well, right away I see the red flag. I've got a negative exponent, so it might be helpful to rewrite this base with a positive exponent first. So since it's implied this base is being divided by 1, I just have to write it as its reciprocal, 1 over a to the positive 2/3. So I shifted this base to the opposite location, and when I do that, the sign of the exponent changes. So 1 over a to the 2/3. So I still will have 1 in the numerator, and now I can use power over root to help me change this denominator to the radical notation form. So a is raised to power of 2, and cube root is taken. So cube root of a squared. So 1 divided by the cube root of a squared is my final answer. In example 16, we have 4 to the 5/2. So we have 4 raised to the power of 5, and then root is 2. That's square root. Now, if we write the problem this way, we're going to have to take 4 and multiply it by itself 5 times, and we're going to have a really large number that we'll need to take the square root of. So another way that we could think about writing this is to start with the square root of 4, and then whatever that result is, raise it to the power of 5. This means the same thing, but I think it would be much easier to work with taking the root of something very small instead of something very large. Square root of 4 is 2. So 2 raised to the power of 5 is what we're dealing with here. So 2 times 2 times 2 times 2 times 2. That's what 2 to the 5th means. So 2 times 2 is 4. Another 2 times 2 is 4. Then multiply by 2. So that means 16 multiplied by 2 is 32. There's our final answer. Next, 27 to the 5/3. We know that 27 raised to the power of 5, and then we'll take the cube root. So that's going to be a huge number. I don't really want to work with a number that large if I'm working with just paper and pencil. So I would choose to find the cube root of 27 first, and whatever that result is, then raise it to the power of 5. The cube root of 27. Hopefully by now you're recognizing that 27 is a perfect cube. It comes from 3 times 3 times 3. So really what we have is 3 raised to the power of 5. So 3 times 3 is 9. Another 3 times 3 is 9. So that's really 81 times 3. And 81 times 3 is 243. There's our final answer. Now we get to example 18. We have a quantity raised to a rational expression. So that means the quantity of 10x plus 1 is raised to the power of 2, as indicated by this numerator, and we're looking for the cube root of that. So we're done, unless you choose to write it as cube root of that quantity, 10x plus 1, and then the entire value could be squared. So you could write it either way.